In this video, we'll talk about how to convert a complex number in rectangular form, a plus bi, to polar form, which is r times cosine of theta plus I sine theta. And in both cases, I is the square root of -1. So to understand this, what polar form is, we will first need to look at the complex plane, which is drawn here. And we plotted the point 3 plus 4i. 3 along the x-axis and 4 on the imaginary axis. And the idea of polar form is that you can express any point along in this plane as a distance away from the origin. So like, for example, this distance, basically any distance away from the origin, and an angle. And the way angles are drawn is the same way you draw them on the unit circle. Start from the positive x-axis and move counterclockwise. And so, for example, this point 3 plus 4i can be expressed as a distance away from 0 and this angle. And our distance away from 0 is what we call the modulus, and our angle, theta, is called the argument. And so let's see how we can convert a number from rectangular to polar form. So let me just write the polar form here. Okay, so r represents the modulus, or the distance away from 0, and I think we know what theta is. So this line right here is r. And so if we draw this line straight down, and let me just draw this triangle down here, we see we actually have a right triangle. And if we have a right triangle, that means we can use the Pythagorean theorem to find r. So this is a 3, 4, so the legs are 3 and 4, which means the hypotenuse must be 5, so r is 5. Or you can just use the Pythagorean theorem. So r equals 5. And now, how can we find what theta is without using r? We just want to use 4 and 3. Well, we know tangent is the opposite side over the adjacent side. So theta is equal to the inverse tangent of 4 over 3, opposite over adjacent. And if we plug this into a calculator, we get 53.13 degrees. So theta is equal to 53.13 degrees. And now we have r and theta. So let's plug it into our formula here. So the number 3 plus 4i in polar form is 5 cosine of 53.13 plus I times sine of 53.13 degrees. And just like that, we are done. We've converted 3 plus 4i in rectangular form to 5 times cosine of 53.13 plus I sine 53.13, which is polar form. Now let's try to generalize this process. So how can we convert any number, a plus bi, into polar form? Cosine of theta plus I sine theta. Well, let's try to visualize this. So a just means the distance to the right from 0, so let's just give it an arbitrary distance, a. And b is the distance up from 0, so let's just give this an arbitrary distance, b. So that means our intersect point would be about here, and we have this. We can draw a triangle like this. This length right here would just be b, and then this length right here, we've said previously, is r, because it's just a distance away from 0. So to find the distance of r, we use the Pythagorean theorem. or the length of r. R is equal to the square root of a squared plus b squared. And this is just the Pythagorean theorem. And now, how can we find this angle theta? Well, we've established before we wanted to use trig. So theta is equal to the inverse tangent of b over a. Because tangent is opposite over adjacent. And so these are just the two formulas you need, but if you ever forget them, you can just draw the complex number out and then use your this line of thinking in order to deduce these. So let's try to do one more problem. So we're going to convert 8 minus 3i to rectangular, or to polar form. So the modulus r we find by the Pythagorean theorem. So 8 squared plus negative 3 squared square root. We get 64 plus 9, which is equal to 73. So r is equal to the square root of 73. Next, we need to find the angle theta. So theta is equal to b over a. So negative 3 over 8, and the inverse tangent of that. So the inverse tangent of negative 3/8 is negative 20.56 degrees. So negative 20.56 degrees. And most people would actually want the angle theta to be between 0 and 360. So let's just add 360 to this number to find a coterminal angle, which is 339.44 degrees. So this is what our theta is. Now, does this make sense? Because we know that sometimes there can be two solutions. In this case, let's draw it out. 8 would be somewhere here, negative 3 would be here. So 8 minus 3a should be somewhere where this circle is. 339 degrees would get you somewhere here, which is about right. It's in the same quadrant. So 339.44 is good. So now, let's finish this out by writing it in polar form. So we have square root of 73 times cosine of 339.44 plus I sine plus I sine 339.44. And just like that, we are done. We've written 8 minus 3i into this form. So next, let's practice converting polar form into rectangular form. So we're given 8 cosine of 39 plus I sine 39. And we're asked to write this in a rectangular form, which is a plus bi. Well, this is much simpler. The way you do this is just you distribute this 8 and plug your expressions into a calculator. So we have 8 times cosine of 39, which is 6.22. Next, we'll do 8 times sine of 39, which is 5.03. And so this first term up here is A, and the second term is B. So we have 6.22 plus 5.03i. And just like that, we're done. So converting from polar to rectangular is much easier. You just need to distribute this 8 or distribute your modulus and then plug your expressions into a calculator to determine the a and b values for rectangular form. I hope this helped.